We are now in the outer bailey of the hill fort Tismice near Český Brod. The Tismice hill fort was a very important centre at the end of the 8th century and in the first half of the 9th century. Fortified strongholds were built from the 8th century in Bohemia, Moravia, and a part of Slovakia. This differentiated these areas from the actual Avaria in the Carpathian Basin, with its core in the territory of today's Hungary. It was a production centre where we have evidence of craftsmanship. We think we know of at least one reason why it was built at this elevated area, to this day called Na Hradišťatech. This is because there are malachite, azurite and other copper ores on the hill fort slopes, which allowed them to produce copper right here. This hill fort has been systematically researched since 2014. Here, we have found a complicated stratigraphy of finds from the 8th and the 9th centuries. The most important things we found were the proof of fortifications and the evidence of craft production. In one of the trenches, we found a crucible with gold. In other words, a melting pot for making jewellery. And in 2022, less than 80 meters from it, we found one such local goldsmithing product, and that is a golden bead, the production of which we are reconstructing. Apart from that, more than 140 bronze fittings of belts and horse harnesses were found here. These are the most remarkable proof of the presence of the Duke and the social elite of the time. The Tismice hill fort is one of the 7 largest hill forts in Bohemia. It's spread over about 21 hectares, but we cannot rule out that it was even larger, as in one place the hill fort is damaged by the modern quarries. The finds from Tismice show us 3 significant things. Firstly, the hill fort lay next to a long-distance communication, which was later called Trustenitz Way, that is to say, leading from the Middle Bohemia and Prague area to Moravia, and even further away. Secondly, there was craft production the likes of which we cannot document this well anywhere else in Bohemia. And thirdly, the Tismice hill fort belonged among the trio of the most significant objects in Bohemia at the turn of the 8th and 9th century. Before we had a project focused, among other things, on the Tismice hill fort, such luxurious jewellery in Bohemia was usually thought to have been imported. Since we found 3 variants of fittings in Tismice and also a full set of tools in its outer bailey, containing a hammering die and goldsmithing tool and other such tools, the jewellery production in Tismice is evident. We have deliberately chosen 3 things. A unique find of a hammering die, where we reconstructed the hammering process and made a replica of a horse harness decoration. Such decorations were usually made from silver or sometimes from gilded bronze. This process had never before been reconstructed. Then we chose a gilded animal head, which was probably a stylized boar's head, as we can see a hint of a tusk. Similar decorations appear in the area from Bulgaria to the Czech Republic and from northern Croatia to the once again Czech Republic. Our sites with such finds are the most Western ones found in Europe.
We gain insight into how people lived, into their knowledge, their level of craftsmanship, by accessing the artifacts they manufactured, and also from experimental archaeology. We try to imitate their work, using the technologies and tools that were available at the time. This gives us many answers, but also many questions. We know that smelters and metalsmiths worked in Tismice, and we have an idea of the tools and processes they used. The technique of metal casting was very popular at the time. Beautiful and unique ornaments for horse harnesses and belts were made using it. The casting was done using one of several types of casting molds. We will show you the lost wax casting technique. In this technique, The craftsman first made the shape of the wanted product out of wax and then added a drain channel for pouring metal into the mold later. Once such a wax model was finished, it was fully covered with clay so that only a little part of the drain channel was peeking through. And then it was left to slowly dry out for several weeks. When it was all dried up, the craftsman put it into the kiln with the drain channel's mouth facing downward so that all the wax could flow out. This created a hollow in the shape of the desired product. The craftsman left the mold in the fire so it would be heated to the right temperature and filled a prepared clay pot, more precisely, a crucible with bronze. Melting of metals was done in a clay oven with charcoal and adding air by bellowing. The needed temperature exceeded 1,000 degrees centigrade. After the bronze melted, it was poured into the clay model. Once the clay model cooled, the craftsman broke it, took out the cast, cut off the drain channel, and added the holes for attaching the cast. The cast then had to be cleaned with a file or scraper, or loose fine sand applied on the surface with a piece of leather or textile. This was followed by polishing with an agate stone, smoother or crushed charcoal. After polishing, the jewel was gilded with gold amalgam. However, this method was very harmful to health, and the craftsmen doing this work were exposed to the fumes of poisonous mercury. The finished product was placed on the horse's harness using rivets. This was done by hammering the wire into a broader head on one side, threading it through the ornament, and then through the leather part of the harness, horse harness, in which holes had been previously made. On the underside, the rivet was fitted with a little metal sheet with a hole, and then its end was flattened by hammering. In this way, ornaments, fittings, were attached to both horse harnesses and belts. Another type of jewelry found were delicately hammered sheet metal fittings, so-called roof-shaped decorations of horse harnesses. Metal hammering dies were used for their production, and one such form was found in the outer bailey of the Tismice hill fort. The following procedure will show how these horse harness fittings were made from a thin silver sheet. For the experiment, a replica of the die was cast. Since silver was an expensive material, it was used in the form of thin sheets for the sake of the economy of material and maximum effect. The sheet had to be manufactured first. From the silver ingot, the craftsman produced a thin sheet by successive hammering on an anvil. In the course of the work, it had to be annealed to soften it for further processing. This was done by placing the silver sheet in a furnace, heating it to the required temperature, and then cooling it. The craftsman estimated the necessary temperature based on his experience. If the metal was not heated, it remained hard, and defects could form during subsequent processing. If the temperature was too high, the metal would melt. Before the actual hammering of the silver decoration from the sheet, the bronze was first hammered into a lead block until a hollow in the shape of the die had been made in the lead pad. The silver sheet metal was laid over the hollow in the lead pad. The bronze die was placed on top of it, and atop it, a wooden peg. The craftsman was striking the wooden peg with a hammer, thus pushing the silver sheet and the bronze die into the hollow until the sheet formed the desired shape. Then, the decoration was cut off the rest of the sheet metal and filled with pitch from the reverse side so it would not deform by usage. The pitch was made of a mixture of resin, wax, ground coal, or clay. To fill all the crevices of the decoration, the craftsman heated the pitch. After the pitch cooled down, the decoration was polished with finely ground charcoal, and the holes for attaching it to the harness were made on the sides. One horse harness required about 10 such decorations. The work with gold as the most precious metal was performed under close control of the Duke, which is probably why we can locate it in the area of the second inner moat. The remains of a crucible with traces of pure gold, pottery shards, and a gold deformed bead were found in Tismice. We will try to reconstruct the original appearance and production method of this bead decorated with filigree wires.
We decided to rebuild the golden bead because it was so deformed that even visitors at the museum would not be able to imagine what the bead had looked like. First, we created a digital model. Then we decided to recreate the production process step by step because new techniques appeared there, such as the middle joint of the bead. We needed to see in practice how difficult that was to make, and it also allowed us to measure how long the creation of such a decoration took. Or more precisely, how long it took to craft for a skilled craftsman if nothing went wrong. The find of the golden pearl is extraordinary, even though it is deformed, because it is one of maybe 2 golden finds from settlements outside of grave contexts. It is the earliest evidence of such workshop production in Bohemia for the early Middle Ages. Such jewelry was meant for the women of the Duke's court. It is true that there wasn't just one duke in Bohemia around the middle of the 9th century, there were more dukes. But the goldsmith obviously worked for the one who had had the whole 21-hectare Tismice hill fort built. The Duke of Tismice was one of the 15 most important people in Bohemia at the time. The bead is unique due to the combination of several techniques, primarily the middle joint with its pseudo-filigree, that was created by a different technique as we discovered during definitive study and under the microscope. When we study some of these jewels without the microscope, we may not be able to distinguish between several techniques because, without the large magnification, these often look very similar. The goldsmith must have been extremely skilled and had very good eyesight, since nowadays we help ourselves by using microscopes and magnifying glasses, but these were not available back then. While the goldsmiths now use all these things, he had to do it with all the precision we have seen under microscopes, without these tools.
The bead was spherical and decorated with several types of filigree wire decoration. Beaded and block-twisted wire and pseudo-wire filigree decoration on the border in the middle of the pearl. The procedure was such that the gold cast was first of all hammered on an anvil into sheet metal, again with necessary intermediate annealing. The wire was hammered from the gold cast on the anvil and gradually thinned by hammer blows. During the hammering process, hammer marks were formed on the surface. To make the wire perfectly round, however, it was stretched through the draw plate. This was an iron plate with holes of various sizes. When the wire was close to the desired thickness, the craftsman would stretch it to a point at the end, thread it through the hole in the draw plate for the production of wire, and pull it through the hole with pliers. This was followed by pulling the wire through a smaller hole, where it got a perfectly round profile. The discs were drawn on the sheet metal, which the craftsman cut out and molded in a dapping block. During the shaping, however, the overlap of the sheet metal was deliberately left and was hammered into the hem of the hemisphere. The hemispheres were pierced in the middle to create holes. The rings were formed from beaded wire. This was created by grooving with a double-edged tool, which extruded one bead at a time by rotating it on a pad. This process was repeated until the entire wire was decorated in this way. This was followed by the preparation of rings placed on top of the metal bead around the holes. The beaded rings were placed around the holes of the hemispheres so that the overlap created by poking the material out fixed the ring in place before soldering it so that it could not shift. The joining of the hemispheres was done by soldering using gold solder. Pieces of solder were placed in the joint, and soldering was done in the furnace or kiln. The protruding edge in the middle was polished with a stone smoother and grooved with a double-edged tool, the same one used to make the bead wire, to create a sort of pseudo-filigree wire. This was very clever, because the craftsman could clean up the joint very well this way and decorate the place at the same time. The bead was further decorated with small filigree rings of block-twisted wire. This was made by hammering the round wire into a flat profile and twisting the resulting flat profile in pliers. When the filigree wire was finished, it was twisted into a spiral with pliers and cut with scissors into individual rings, which were soldered onto the pearl. It is clear that the craftsmen of this period were able to produce sumptuous jewelry and ornaments. This bead demonstrates the art and aesthetic sensibility of the craftsman who used several decorative techniques. It is evident that he gave a lot of thought to how to most effectively clean and decorate the joint. He had played with the positioning of the top rings around the holes so that the object soldered well due to the overlap of the sheet metal created by punching the holes. The sheet metal he used to create the jewel is very thin and regular. It was perfectly shaped and evenly hammered. There are no defects, which serves as proof that the jeweler who crafted the bead was indeed very skilled and experienced.
I think this was a great experience because we got to see the whole process, which is rare. It was also very helpful because we could see all the problems that are not normally shown. This means we now know which steps in the process are the risky ones, the places where even if you try very hard, it can and often will go wrong. It also showed us just how hard it was to hammer out the golden, or in a much harder case, silver sheet.